This video is about introduction to hypothesis testing. Hypothesis testing is a type of statistical analysis that tests an assumption which applies to a population like the mean, variance, or independence of variables. There are two kinds of hypotheses: null hypothesis HO and alternative hypothesis H1. The assumption we want to test is called null hypothesis HO. Alternative hypothesis H1 is the opposite of null hypothesis HO. After calculating the test statistic, reject HO or not reject HO, we never say accept HO because HO is an assumption. It's not the fact. So we never say accept HO. Key points to remember. A test statistic is always calculated based on the assumption that the null hypothesis HO is true. Here are steps for hypothesis testing. State HO and H1. At certain significance level alpha, if p-value less than alpha, reject HO. Significance level alpha normally is 5%, 10%, or 1%. Then find the degree of freedom and calculate test statistic and a p-value. Then you can draw the conclusion. If a p-value less than alpha, enough evidence to reject HO. So rewrite H1 at the certain significance level. If a p-value greater than alpha, not enough evidence to reject HO. Rewrite HO at the certain significance level. Let's talk about HO and H1. Since all the test statistic and p-value are calculated under the assumption HO is true, normally HO is connected with the following words: being equal, such as no difference, the same, no change, or equal to. H1 is opposite. It's connected with inequalities, such as not equal to, greater than, less than, different from, changed after something. For HO, we use the words follow certain distribution, such as normal distribution, binomial distribution, and uniform distribution. Uniform distribution means every possible outcome has an equal chance of happening, like standard die and so on. Opposite to HO, H1, we always use the word doesn't follow certain distribution, like the coin is biased. For HO, we always say no relationship between variables, or the variables are independent of each other. Opposite to HO, H1, we always use the word there is some relationship between variables, or the two variables are dependent on each other. Other concepts. Significance level alpha is the probability of rejecting the null hypothesis when it's true. In practice, we take 5%, 1%, or 10% level of significance. The researcher determines the significance level before conducting the experiment. Here is the rejection region. When p-value less than this alpha, reject HO. A p-value measures the probability of obtaining the observed results, assuming that the null hypothesis is true. When p-value less than alpha, reject HO. We will use please reject HO to remember this. This p means p-value. L stands for less than. S stands for significance level. Then reject HO. Critical value K is an essentially cut-off value, just like this, that define regions where the test statistic is unlikely to lie. If the test statistic lies in the rejection region, reject HO, which means test statistic greater than K, reject HO. You can remember these two together. This is a greater than. Here is a less than. Degrees of freedom are the maximum number of logical independent values. df equals n minus 1. N is the number of items in a data sample. You can use the seats in this car to understand the degree of freedom. Think about 6 people will sit in this car. Only 5 people, only the first 5 people who entered the car have the freedom to choose the seat. The last person has no freedom to choose the seat. In other words, the degree of freedom equals 6 minus 1 equals 5.